title is Non-Isolated High Voltage Gain DCDC Converters based on 3 SSC and 5 VMC. This is a project in Integral Coach Factory, Perambur, and the project is presented by Aravind A.S., Shakti Raghunathan N., Yashwant M. We are from Veltech, High-Tech, Dr. Rangarajan, Dr. Shakuntala Engineering College. Our internal guide is Mr. Pradeep Katta, ME, HOD Assistant Professor, EEE Department, and our external guide is Mr. Sharif, SSC ICF, Perambur. And the objective of our project is to give continuous input current with less ripple, to reduce heat loss, to increase voltage gain, to provide backup in case of an emergency. Abstract: the high step-up DC-DC converter with 3 static switching cells and voltage multiplier cells provides continuous input current with reduced ripples and high voltage. The voltage increases by cascading several voltage multiplier cells constituted by diodes and capacitors that operate on a resonance principle. The voltage stress across the element is reduced due to clamping performed by the output capacitor. Transformer based boost converter. This is the conventional method. The DC-DC converter to set up the voltage level using transformer. This converter that uses the transformer to increase or decrease the output voltage, that is stepping up or stepping down, and provide galvanic isolation for the load. With the multiple output windings, it is possible to provide both higher and lower voltage outputs. Here the secondary windings is more, secondary leakage inductance is high, filter values are high. This is the mentioned or the disadvantages. Here is the circuit, and next we are going to our proposed method. In this proposed method, we are replacing transformers by SSCs and VMCs. The proposed DC-DC converter has 3 SSCs and 3 VMCs cascaded to produce the high voltage gain. Here is our proposed circuit. We have several disadvantages over the conventional method that uses the transformer. Some of the advantages are continuous input current with low ripples, reduced voltage stress across the switches, high voltage gain, reduced size and of the input elements, high efficiency. And the mode of operations, we have 3 modes of operations. Mode 1, switches S1 and S2 are turned on, while all diodes are reverse biased, energy is stored in inductance L. And in mode 2, switch S1 is turned off while S2 is still turned on, and diode D5, D3 and D1 are forward biased. While in mode 3, switch S1 is turned on while S2 remains turned off, diodes D2, D4 and D6 are forward biased. This is the modified circuit diagram of our, which consists of 3 SSCs and 5 VMCs. Here there are 5 voltage multiplier cells are cascaded, and hardware block diagram. We have the supply of 5 volt to the buffer and the microcontroller. The opto isolator isolates the buffer and the controller circuit, and the multiplier cells from the cascaded booster converters. We have the simulation circuits and waveforms. This is the transformer based converters, that is our conventional method. In the conventional method, we have given the DC input of 50 volt, and here's the triggering pulse using the MOSFET, and the output in the conventional method will be around 270 volt. Next, going to our method, that is proposed method with 3 VMCs. This is the circuit for the 3 VMC cells, and the input given is same as 54 volt, and triggering pulse will be given with 2 MOSFETs, 2 MOSFET switches S1 and S2. The output of 3 VMCs will be around 400 volt, and next goes is our method with 5 VMCs. This is the circuit for our 5 VMCs, and the input given is the same 54 volt. Here is a triggering pulse with the same MOSFET switches, and the output obtained is 680 volt. This is the overall circuit for using MATLAB software, and this is the project kit overview, and the working condition will be shown here. The input given is around 12 volt, 11.58 volt, and the output obtained is about 280 volts. Thank you.
Myself Shakti Raghunathan, and my batchmates are Aravind and Yashwant. We are from EEE Department in Veltech, High-Tech, Dr. Rangarajan Dr. Sakabala Engineering College, and our project is non-isolated high voltage DC-DC gain converters based on 3 SSC and 5 VMC. The main objectives of our project are to provide less ripple on output current, to provide backup in case of an emergency, and to provide high voltage at the output. The conventional method of our project is we are using transformers for getting high voltage at the output with the help of transformer ratio, increasing and decreasing, which in case increases the voltage and decreases the voltage. We have used voltage multipliers by cascading capacitors on one another, which gives a very high voltage at the output. And here's our kit. The kit consists of a power circuit, controller circuit, isolator circuit, and voltage multiplier circuit. Here the capacitors are cascaded on one another, which gives a very high voltage at the output. Now, previously they were using transformers to get a very high output, which becomes very bulky and which reduces efficiency, which also produces heat. So this eliminates everything. The kit is very much thin and it helps in giving very high output.
This is the power circuit. This is the power circuit that is given to the voltage multiplier cell, and this is the controller circuit where the microcontroller and the buffer are placed here. This is the optocoupler, two optocoupler for the two MOSFET switches. Here the MOSFET switches are molded to reduce the short circuit and getting coupling. To reduce this, the MOSFET switches are molded. And this is the power circuit for the optocoupler. For two optocoupler, we are using here generally we are using a transformer with 232, which is stepped down to 230 to 15 volt. These are two transformers, one for the given mark for the VMC power circuit and the other for the optocoupler for the isolated power circuit. This is the component. The 15 volt is given to the bridge converter where the DC is converted to AC, and here we are getting 15 and we are supplying the 15 volt. We are supplying 12 volts. We are supplying 12 volts to as input, and the output obtained we will be getting is 280, about like that. This is the bridge converter for the optocoupler, one for one optocoupler and the other for the other. Where the optocoupler is TLP 250, obtained is TLP 250. These are two optocoupler. This is the microcontroller where the opt is burned, and then this acts as switches. These are access switches. This is the microcontroller. This is buffer, where the buffer and the microcontroller acts as control circuit for the controlling the MOSFET switches. These are molded for reducing the short circuit and the other cables. These are diodes, which are basically of 1N4001 to 1N4007, and these are the capacitors, which are of 10 microfarad. Then here the running of our project. Here the given input is of 11 volts. We can see that the given input is of 11 volt and the output obtained is about 280. Yeah, generally it's the same. Here we are multiplying voltages with the 5 VMC cells. We are multiplying this much. This is generally a ordinary prototype model. So we are obtaining here. Here when we give about input of 230 volts, we can get about 1000 volts and etc. This is the basic working model of our project.
Thank you.
Thank you.